So now we try to implement Kafka. So for Kafka, what I do is I will take another service for Kafka. So we need a Kafka dependency. So Kafka dependency already we have. So then we need to go for application properties, where we need to add the Kafka port number. So our my Kafka is already running in the system. So on which port number? Usually it will run on default port, that is 9092. So it has to run 9092. Yes, it is running on 9092. So now these two are for key serializer and value serializer. So whenever you send any data to the Kafka, it has to be serialized and then it has to be stored. So if it is a object, then we need a JSON serializer, but we are now storing strings, so we need a string serializer for key and value, as well as we need deserializers for key and value. So once these properties are there and once this dependency is available, now I can simply go to the services. So we'll create a new service. I say this is Kafka service. So in this, simply what we do is we'll take a Kafka template and we'll try to receive the data. So whenever Kafka receives the data, it has to push the data to the sinker. So that is message sinker. So when the Kafka receives data, that will push it to the sinker, and whoever all connected to sinker, they will receive the data. So this pushing the data to the Kafka can be from any application, not from the same application. It can receive data from some other application also. So Kafka acts like a global, or you can say shared, where the data can be stored and received. So we'll say Kafka template. And then we'll move to a method void push message, which will push the message to the Kafka. So Kafka template dot send. So here I will use my topic, and message is message. My topic is fixed. So there is another parameter if you want to pass group ID also, I think. Okay, group ID is not compulsory. So we'll say message. So this is for pushing the message to the Kafka, and we write another method, that is receive, that is listener, who listens the data. This is Kafka listener. I declare it as Kafka listener, and this Kafka listener, what it will do, whenever Kafka receives data, this listener will be executed, and whatever message is there in the Kafka, that will be passed to this parameter, message parameter. And from here what I do is, I want this message to be pushed to the message sync service. So I need message sync service to be available here. So I say message sync service, and I say auto wire. And whenever I receive data to the listener, I simply push that to the service, push to sync and a message. So now whoever connected to the sync, that is here, those will get the data. So now in the message controller, I wrote a action which is to actually send a message to sync directly, but instead I want this message instead of sending the message to the sync, I want the message to be pushed to the Kafka. So then what you can do is, you have Kafka service. So Kafka service will take Kafka service and provide. So now instead of pushing to the message sync, I will push the message to Kafka. So once the message is pushed to the Kafka, then Kafka listener will be executed. Listener will push the message to the sync. So whoever all connected to the sync, they will receive the data. So that is the concept. So now first we push message. So this indent.html we wrote in the same application. So there itself there was a small confusion. So usually when we want to push anything to the Kafka, then there is no need of this message sync. Directly, there is no need of Kafka actually. You can directly push the message to the message sync, and whoever all connected to this flux, they will receive the data. But why we need Kafka here is, if you want the data to be transferred from one application to another application. So message sync is only within this application. Within this application, if you want to pass messages, then flux and message sync is enough. But if you have two applications, or you can say you have two MVC applications, or you have one MVC application and multiple microservices, and you want the data to be transferred from one microservice to another microservice, or from one MVC application to another microservice, or one MVC application to another MVC application, then you cannot use this message sync. Message sync class can be used within the same application. Within the same application, multiple controllers. You can have multiple controllers within the same application, and we can any controller wants data, then they can simply connect it to this message sync. They can access the data from any controller. You can push the data to message sync, and whatever controllers are subscribed to the sync, they will get the data. But that happens only within the same application. But if you want the message passing to be done in different services, microservices, or different applications, then you need to have some shared server or you can say global, where you can store the data and you can receive it. So that is the concept. And I want live data, so that is why we are using sync here. because if you want live data, then we need to use flux and sync. So that is, so as of now we have only one application, and this index.html is pushing the data to our controller. From the controller it is sent to Kafka, and Kafka service, whenever receives the data, Kafka listener will be executed, and this listener will get the data and pushes the data into the service, so that any other application connected to subscribed to this sync service can get the data. So you other applications cannot directly access this class. So other applications can access the controller and this action, and this action will return the sync to the other applications. So once sync is the other application is subscribed to this particular sync, then what happens, whatever data it receives, that will be pushed to that particular client or particular application. So that is the concept. So now we'll run. So Kafka is however running. So we run this. Topics pattern must be provided. So where is the error? Application failed, exception, cancelling, topic pattern. So provided, I don't know where it is. I think listener listener will take so we need to provide the topic here. So topic is my topic, because you may have a number of topics, so listener should watch which topic, so that you need to specify, otherwise the listener won't connect to that particular topic. So you can see it has now connected to my topic, and the group is my group. So we have only one group, otherwise you can give here group also. So now we can go to 8080 port. So assume that we are sending the data to the Kafka from some other application, but as of now I don't have other application. I am doing everything from the same application. So otherwise you can create another application, from there you can send the data to the Kafka. So I say message, when I say /message, whatever HTTPS we will remove. So now we got the message, and now I say hi, then submit. So then it should be submitted. So I think it is. So I say hello, submit. So we can see hello here. So it is receiving the data. I say how are you, submit. So how are you, but I want a another tab will take, so where we will register to our flux or sync. So this is one app running, and this is one app running. So here we will connect to our sync, that is sync or flux, whatever. So here message /stream I say. So you can see we connected and we got the data. So now whatever you send, automatically the data is now pushing to the Kafka, and from Kafka you can see our stream is getting. So if you have another browser, you can test this in different systems also. So as of now I am doing in the same system, but you can have uh, multiple systems, and Kafka can be accessed from any system. So then you have to give the IP address instead of simply saying localhost. You have to give IP address. Then what happens? From anywhere you can send and receive the data. So I say stream. So you can see both the clients are receiving the data. So this is how you can use Kafka and Spring streams, Webflux, MVC, all combinations. So then instead of directly using the stream, something like this, you can also use a JavaScript. You can use a JavaScript code, a small JavaScript code we have to write. So that JavaScript can be used for displaying the data. So JavaScript should be written in the HTML only. So what I do is, instead of writing another action, I can write another action for displaying the messages. We'll write another action. Better to have another action, so which will show you the messages. I say show messages is another action. I say this one @. So here what we do is simply I say show. So here what we do is simply we'll return a HTML. In that HTML we will write a JavaScript code. That JavaScript code will simply display the messages. So if you see here, when I connected to the stream, you see the browser is waiting. So when you get the data, then we can see the message. So you can see the message like this, but you can see the browser is waiting here. So that means the browser is waiting means you cannot do other actions. Here the browser is blocked, but I don't want that blocking. So whenever I get a message, I should able to display the message, but without blocking my application. So if you want to do something like that, then you need to go for writing in a JavaScript. I say messages.html. So here I will write a script. The script will use a concept called SSE, that is simple text event stream SSE. So server sent events, that is the concept. So server sent events, so we can simply create event source object whenever it receives data. then on message a method will be executed. So here you can see it is a function, lambda function. This function will be invoked whenever the event source will get the data. So here you will be giving that stream which we have created, that stream, and here we are telling that whenever message comes in you need to execute this function. So that is the code, JavaScript code. So whenever it receives, then that data we can just display. So for displaying, again we write a JavaScript. So here they are using li, that is list, event list. List is something like a list box. Here in HTML we call it as list and li's combination. So li's will be added to the list. So that is the code. So I will copy this code into the script tag, and here I need a event source object, so that also, and so I don't want this with the credential something. I remove this. It should work without that also. So here what we do is, here we'll give our stream. So what is our stream? So URL, and here we'll say stream. So now event source is now connected to stream. Whenever it receives data, this particular method will be executed, and event contains that object, whatever object we were seeing in the this one. So here we'll say stream. You'll see when connected, and when you send anything from here, we are receiving as a data colon message. So that is what here we are saying, event dot data. Then you will get only this message, that value you will get. So data is the key, and this value is the value. So only we are displaying this message, not this data. Data is the property. So event dot data. So that's all. Now event list we need to add it to the body. So here I will take a div tag, and I say div tag id as container, and this event list, whatever event list is there, we created here the list object, that I need to. Otherwise what we do is we create list only here instead of, because we are accessing list directly here. So I take here I will take in HTML I want a list. So how HTML list, how we write HTML list tag. So this is HTML. So UL will be there. In the UL there will be a line. So it looks like it will be like this. So we will write here UL, and UL ID equal to, will say list. That's all we will do. Now this UL we are accessing here by using get element by ID. List means this UL will come into this object, and this is a new li. Every time we are creating li, we are adding the data to the li, and then li is added to the ul. That is what the JavaScript. So now we open our new tab will open it separately. So now what we do is we connect to our messages URL. So I will connect to messages. So when you connect to messages, you will get that message/messages. What is that? Okay, we need to restart because we modified this one. So I need to say show, not messages. Sorry. So we'll say here show. What happened? Something blocked, I think. Yes, now I think yeah, now it is connected. So I say show. You can see nothing here. UL will not display anything there. So now I will say hello. You can say submit. You see we got the hello. So I say hi. You can see hi. You can see something. You can see something. So like this you can use JavaScript, and now you can see it is not blocked. So that is how you can use Kafka and sync. So sync is only for streaming the data. You can use sync and flux, otherwise not required. So with this, what is the thing is, by using Kafka, what you can do is you can send messages from one application to another application. The application can be MVC application, the application can be a microservice. So the next thing what we why we need Kafka is, when you have microservices. So in the microservices, if you want to transfer data from one microservice to another service, or if you want to give some instruction to another microservice, then we used to use this Kafka. So what is that instruction? Why do we need to give instruction? Means here for example you have two microservices. One is order microservice, another one is product microservice, another one is payment microservice. So now if you want to after customer orders a product, order microservice should give an instruction to the payment microservice that some order is received, and it has to do payment process. Once payment process is done, then again payment process should give an instruction to the order process that payment is successful or payment is failed. Once payment is successful, then order service should give an instruction to the customer that order is successful. So something like that we need to do, but usually this can be done with the help of transactions, but transactions can be executed within the same application. Transactions can be within the same application, but if you want transactions globally, so global transactions not possible, not available, not possible. So for doing that transactions globally, we use Kafka, and there is a concept. That concept is called saga pattern. So this is the pattern we use. Whatever pattern I explained to you, that is called a saga pattern. So in this saga pattern we can use Kafka for implementing saga. So saga pattern implementation. So the same example: order created, customer validated, payment processed, payment failed. This is only we call it as saga pattern. In the saga pattern again you have two ways to implement saga, that is saga choreography is there, saga orchestration is there, but as of now we won't go for that. So you people should do implementation of these two patterns, but initially you practice this Kafka, sync, MVC. This you practice once this is done, then we'll see how to, then you people have to do microservice with Kafka and the saga pattern.